Okay, everything you wanted to know about frequencies. Yeah, I think the issue with frequencies are always challenging. And the question about bands, it gets worse. They stick N in front of it. N band something means it's a new radio. It keeps evolving. But I believe this comes from the 3G PPP standards community. Where it's kind of worldwide. They're worldwide frequencies. So you got to be careful when you're changing things. You got to have agreements and votes and everything to do that. So let me get back to the next technology area, which I mentioned was software-defined radios. And so one of the things when you have all these frequencies to deal with, it's hard enough to say, well, band 103 or band 48 is CBRS. They kind of have common names as well as frequencies and bandwidths associated with them. The role of the software-defined radio, as I'll explain, is very key in as much as you can actually, once you have the 3G PPP stack on the radio, you can configure the radio yourself. Now, what does that mean? Well, it doesn't mean you have to be an expert in it. You can set your transmit powers, your receive powers, your subcarrier, number of subcarriers, the subcarrier spacing, all these things you can control to the extent it's necessary for your application. So that's really the power. Plus, you can move the frequencies around, and that's a real, flexible feature because you've got these odd frequencies, that you're using, and then you try to use those. And also, if it's very narrow band, you can still apply the same control parameter or configuration parameters to a narrow band. It doesn't have to be 10 megahertz or whatever. So that's a very important part. So with our NIST program, one of the, I'll explain kind of what we're trying to do there is really the challenge of interoperability between broadband and narrowband LMR. So I'll explain some of the challenges there, but basically that was the objective, that coming back to voice, and really that's the message, voice and standards. Voice is often, it's more often used it is used in LMR, obviously. And the question is, how do you get the interoperability? And that's really the purpose of the development. Go ahead.
There may be some who don't know what NIST is.
Oh, okay, NIST. So let me explain. So NIST is the National Institute of Standards and Technology. So the particular group we work with is, everyone has an acronym, PSCR, which is Public Safety Communications Research Group, right? So that's kind of their charter in life. And they get equipment from all the equipment providers that you know and love. And they kind of evaluate it in terms of, does this address the needs for public safety for them? Is it like, do the firefighters, first responders, objectively, what's the feedback, surveys, is this the right way to go? And where are the gaps in the technology? And that's kind of where we're adding value to what they're doing, right? So the particular radio that, actually you'll see this downstairs, this is a the 5-pound radio. It supports, and it has a full 3G PP stack on there that can do, you can either configure it to run 4G LTE or 5G standalone operation. And so that's quite a unique development. And as a 5-pound unit, let's say 1 watt, we see that in terms of use case, like cellular on wheels. This is almost like a cellular on a fire truck, or even on somebody's backpack, with some limited, half-hour operation, where everything's lost, all is lost, and people are trying to communicate. They may not, their P25 system may not be working, or they have, it's a redundant application for those systems. So, and obviously a number of other use cases. But basically, the software stack is loaded onto a processor, and then those drivers, which are the 3GPP drivers, drive the actual software-defined radio, which changes the frequencies and so on. And then the front-end module gives you the higher power as required. And so roughly, if you get it up to about 1 watt, you probably can cover a mile, with pretty reasonable coverage. So that's kind of the basic building block. So for interoperability, what we do there is in the purple here is the radio itself. Then it's tied into a mission critical push to talk server, which is again a standalone unit. And then this is the LMR system, which is connected through a fiber to the LMR. And the block in the middle here is the ISSI. I don't know who is familiar with that, but basically it's called inter-subsystem interface, which essentially can translate voice from the broadband to the LMR application. So this particular white block is, there are standards for that as well. There are ETSI standards for that. However, in industry, each vendor has, I'm compliant with the standard, but they're not compatible. Okay, so that's a real issue. If you think of like a UE on broadband, you've got your iPhone, you can plug in different SIM cards, you can have multiple SIM cards in your unit, and it doesn't really care, it'll communicate with the network, right? So that's just fine. However, when you get into trying to communicate with the LMR, which uses the authentication, the key to fire up your subscriber units, that also is taken care of, but that link is the key thing, and that's why this is an area that we're addressing in terms of standardization and looking for ways to simplify that process. So to date, we have demonstrated band 13. Sorry to use these numbers, which is the Verizon. Verizon. Band 54 is the AT&T FirstNet, which is obviously a very broadly utilized application for public safety. Band 54, which Bob mentioned, is the other one we're looking at for high power applications, TDD applications. And I didn't mention others like band 48 we've already done for CBRS. In that case, that system was used for factory automation, as an example, where taking advantage of the low latency in 5G, so in a factory environment to implement that in a factory. So basically, again, the message is that we're using the standards overall and configuring the radio according to those standards. So, and that's the development that we have underway. So I mentioned then, these really the highlights, the fact that we've got the seamless, trying to get seamless operation between the broadband and LMR. And the other function, again, for public safety is this mission critical push to talk. And we've heard that here, but some of them are what you call over the top, which actually don't use the network, but they do use the radio or internet connection. That's basically what allows us to do the evolve the network. So another subject area, and this is probably a little bit further out here, is adapting what are called network observability using AI techniques. And I guess the buzzword we're using there is NOAI, just to shorten it. So basically, the issue there is that when you have a very complicated network, and many of the ones we've described, where you've got numerous remote sites, you've got power centers, you've got other relays and other things that you're monitoring, you like to be able to capture that information in a way where you can direct resources in the event of a problem, right? So that is a very, normally what happens, there's an event, somebody calls somebody, there's an emergency, or you get somebody gets a call, you don't necessarily get the big picture of what's going on. And so that's a real application area that we think is certainly fits into the network vision that we have. And I should have mentioned, is that the communication mechanism for the software-defined radio and so on is all IP related. We use IP traffic primarily to monitor the system. So that's kind of what's happening there. So kind of just a thought process of how network observability is already used for data centers, which is obviously a big deal. You're talking about data centers now that have their own utility. Frankly, it's kind of pretty getting out of hand. But basically, monitoring, a system as complicated as that, you have things of on-site power generation, you have electrical distribution, cooling systems, just monitoring the whole system. There are existing tools that data centers use already to do that kind of thing. So they're monitoring basically processing the IP traffic through their system. And so the idea here is to leverage that for private networks. So that's kind of the concept here. So in a private network, this is sort of an example of how that might be done. You've got a lot of shared information. You have SNMP, IoT, SCADA, and LMR, and so on. And you'd like to be able to monitor that, as effectively as you can. So on the right here, you've got kind of a typical site, which would have private cellular communications. You'd have digital I/O, which is detecting relays. You might have some SNMP, IoT, and so on, all active within that site. And then the idea is that you then consolidate that into a switch which generates the IP traffic, where you can apply the network, monitor the network status. So that's kind of where it's headed when we look at how to integrate the existing systems. So some of the other concepts there is where once you capture the information, you can actually create what's called a digital twin, where all of that information can be then analyzed offline while the system is continuing to monitor the traffic. And it provides, I think most of us who've used AI in some shape or form realize that it does provide things that you don't have let's say, the mental memory of all the subtleties that are going on in the system. So we really think that is an area that will be very, very promising. So just in summary, we've talked about spectrum access. We've talked about the SDR utilization for both public safety and utilities. And then the key thing was the interoperability between the narrowband LMR and broadband, which is actually an ongoing development. The intention there is, again, to develop standards that you're somewhat vendor independent for that block that I showed, the ISSI block. And then finally, we touched on this observability concept for understanding the behavior of the network. So that's all we had, and these are some contact informations which in the presentation. And if there are any questions,